I think some data not visible properly. I'll just mention it. I'll check in the. Ten to power of 16 it is, 10 frequency. I'll write the data here. 3 into 10 to power of 16 hertz. Capacitance 1 picofarad. Lambda 425 nanometer. Now, similarly, the same problem. There's a photocell. And to this, what happened? A capacitor is connected. I think this was the question. You read it. The information given is of this much. This is the cathode anode is telling the cathode of a photocell. The one which will emit and the one which will collect will be anode. So this is anode. This is a cathode. And the light is incident. Get into the problem now. So it's telling the cathode is illuminated with a light of constant wavelength 425 nanometer, assuming that all the illumination. Anode current will start at a frequency of. So what do you mean by that? Anode current will start. This is lambda, but it's telling it will start. Anode current will start at a frequency of. Means when the photoelectrons will come and strike at 3 into 10 to the power of 16 hertz. So how to light of increasing frequency, the anode, if the photocell is increasing frequency, total number of electrons reaching the anode is of the order of. So definitely according to the question, so the electrons will come and deposit here. So this plate should become negative, this should be positive. And this will set up an electrostatic field because there is a capacitance, no? And the electron here, the electron which is ejected with maximum kinetic energy. So as it moves, it will experience an electrostatic force in this direction. So finally, so initially what will happen, the electrons, see, like I try to understand. So initially what happened, the photons are incident and the ejected kinetic energy and the energy of the photoelectrons are such that what happened, they'll escape to anode, they'll reach anode. And here what happened, the electrons will flow like this, they'll get deposited. And from here the electrons will leave and will make the total cathode as neutral. because how many electrons it has lost, it will get back from this positive plate of capacitor here. Like that, this will continue. So like that, as the electrons flow like this continuously through the capacitor, then it potential charge across capacitor will build up. Then if charge across capacitor builds up, potential difference will build up. If potential difference builds up here, electrostatic field will build up here. Then there's electrostatic force as it builds up. Electrostatic force acting on electron will build up. Then at one instant open, the electrostatic force is such that it will not permit the electron to reach the anode. So it will go like this and will return back. The ejected electron will not have sufficient kinetic energy to reach the anode and will return back. How many electrons? The total number of electrons reaching the anode is of order. So for that, by the time, how many electrons have reached there? How many electrons means, shall I say, how much of charge? So we have information. So this charge from where it has come? These electrons only flowing. Same question, just I'm trying to ask in different way here. Now what is this Q? Directly write Q. Q should be equal to number of electrons into charge of electron. How to, this Ne is what is asking. How to bring this Ne? Work done by electrostatic force, 0 should be equal to EV naught, or select this potential difference, I'll write it here, V. So this K max, initial kinetic energy, K max, electrostatic force does negative work. Finally, just before reaching anode, they'll come to rest. So K max is what? A constant wavelength, Hc by lambda equal to 0. So Sc by lambda work function is equal to E into V. What is V further you can write? V should be equal to Q by C. Q is what? Ne into E by C. So therefore this Ne, what we can write it as? Sc by lambda work function C by E square. But we don't know work function, what to do for that. He has given some information, no? The anode current will start. The anode current will start. So when the photoelectron emission will occur, only when the frequency is greater than threshold frequency. This is the threshold frequency is giving. So how to replace the work function? So shall we write here? The HF naught should be equal to work function. So in place of work function, what I should write? HF naught. So what is F naught? F naught is this one. So fine. So this is the idea of this problem. Huh? Just do workout here, and I'll go for next one. Huh? So this equation is very important. Huh? You must able to write this. So always show that electrostatic field, because that will help us to write the equation, what actually goes on here. Before that, we'll just discuss the bound electron and the free electron. One concept is there. Let me explain that. No. Can a photon, can it absorb? A photon, can it absorb all the incident? Can electron, can it absorb all the incident photon? A few small things can be asked. So let's analyze that one. So a photon. So what is the energy of photon? Is due to momentum. So this photon, I'll show what all the energy of photon will be due to momentum. And what is the momentum of photon? pH should be equal to h by lambda, and this electron which is at rest. So let it absorb this one. So after absorbing, the electron will acquire a velocity. So mass of electron me. and let it start moving with a velocity VE. So can I apply conservation of linear momentum? This is a photon. No? Applying conservation of linear momentum. Initial momentum of photon should be equal to, finally what happened, the photon is absorbed it completely. That should be equal to ME into V. Then what is the energy of photon? Energy of photon should be equal to energy of the electron. What is the energy of photon? SC by lambda. What is the kinetic energy of electron? MVE square by 2. So what is momentum of photon should be h by lambda. In place of h by lambda, shall I write MEV? So look at the speed of electron. Is it possible for electron to move with a speed greater than speed of light? Not possible, no? So therefore, can it absorb photon completely? The answer is no. So what actually happens here? There's a free electron. I'm talking there's a free electron. The free electron cannot absorb the photon completely. So when it comes here, a part of it will be absorbed, a part will be deflected. So what actually happens here? This is called like a Compton effect, which is not there for syllabus. Where from the Compton effect only what happened, we are concluding this, which is not there for syllabus. Uh, what actually happens is, suppose there's an electron, practically what happens here, there's an incident photon. So let it be, momentum of this be h lambda. This is an electron at rest. After this, the electron will get deflected. And the photon, what happened, will get deflected. So this electron will have energy, say like a PE, or you do one thing, and this particular photon, lambda dash, you call it. This is what practically happens. So they'll get deflected. This is theta, this is phi. So you can apply the conservation of linear momentum along x, along y, conservation of energy also, then you can calculate here. So initial energy of photon is how much? SC by lambda. This should be equal to SC by lambda dash plus kinetic energy of electron. This initial momentum h by lambda. This should be equal to root of 2me ke cos theta plus momentum of this photon will be h by lambda dash cos phi. There's a conservation of momentum along x-axis. Then along y-axis, it should be 0 is equal to 2me ke sine theta minus K is what? Kinetic energy of electron. This is called like a Compton effect. The photon weapon will not be absorbed, will get deflected here. But we assumed most of the problems as if the photon will be absorbed completely by an electron, by a free electron. Not possible. Bound electron can absorb a photon completely. This is a free electron. A free electron cannot absorb a photon completely. If it absorbs completely, then VE greater than 2C will come. Not possible. Okay, you can straight away ask questions, sir. Why not possible? We have here V velocity of electron how much will become 2 times the speed of light. Not possible. So therefore, what we can say that a free electron cannot absorb a photon completely. So this is a partially deflected photon. A part of energy of photon will be absorbed. A part of energy of photon will be like a deflected here. So now, sir, what is this like? How come that energy only part it can absorb, the other part will be deflected? And you see, as if like it's like a particle, no? But again, rest mass. Don't go for assuming anything rest mass. In the classical mechanics, what is the mass of photon? Zero. Only in quantum mechanics we do define it. So all these are based on quantum mechanics. Just for our level, we are just putting some mathematical way of representing things here. This is called as a Compton effect. Can be asked in exams. I think nothing big is there. So we know how to apply conservation of linear momentum. We know how to write conservation of energy. Little bit of collisions, what we learned. Those things we can still apply it. But a bound electron. What do you mean by bound electron? Bound electron can absorb. Where you come across bound electron? Chemistry, atomic structure. When a photon incident on an atom, then atom will absorb, no? And that energy what happen will be given to electron, and the electron will jump to higher orbit. Can it absorb completely? Yes. So a valence electron is called like a bound electron. Like this, the free electron, which is not binded to the atom. Because again, don't say free electron means which is completely outside the material, outside the like a substance. No, the free electron is called as the electron which is free from the influence of atom is called as a free electron, and the electron which is binded to atom is called as a bound electron. Bound electron can absorb photon completely. That we can see in atomic structure. And I think already you come across. They're the one small theoretical ideas which you should know. In books, I think they're given this as like a more than an option, but you should know the background, not just remembering some sentences. That one. So the initial background should come from here. No, so